Hi there. So sorry, here are the belated notes for what we would have missed on Wednesday and perhaps a little more. So there'll probably be a couple videos here, but we're starting. This one is on page 21, where I'm finishing up a couple exercises, examples there before we move on to the section with the properties. So first thing I want to look at here is this one on the top left. So just kind of get us back into it. Remember that with a least common denominator, we're going to want to have that be also the least common multiple for x and y. So, you know, x is just x and y is just y. So in our LCD, we've got to include both of those. And there's only going to be one of each because that's the highest exponent up above. And, sorry, a little... There we go. Get that off of there. Okay, so we are looking at xy for our LCD. So I talk about this as a costume change for the fractions. We are not going to change the value of 10 over x, but we do want to change it so that it has this denominator. So 10 over x, and we want to change it so that it gets xy as a denominator. So we think about, okay, what do we have to multiply by to get xy? Well, we're going to multiply by y. But whatever we do to the denominator, we have to do to the numerator as well, because otherwise it would change the value of the fraction. So that numerator then would be 10 times y. And then I'm going to take that piece, that equivalent fraction, I'm going to take back over here and plug in instead of the 10 over x. And then we'll do the same thing with the second fraction, with the 7 over y. We want that one to have an xy denominator as well. So we multiply that by x, since we started with the y this time. And then multiplying by x in the numerator as well. So 7x is the new numerator with that denominator of xy. 7x, and then this is xy. Now that I have the denominators the same, it's basically just add the numerators. Remember that common denominator, we spend time working on it, so we don't want to get rid of it. We're going to hang on to that. Then this would be 10y plus 7x. If there was any further simplifying we could do up there in the numerator, we do need to do that. There's not, because they're not like terms, and there's nothing we can factor out. So this is really going to be the simplest form for that. So 10y plus 7x over xy. Now the one that is up next on the right, this one has z for one of the denominators, and the other one is z squared. So z and z squared. So my LCD, I only have z's, so z would be the factor that I'm going to use. And then the number of times that I'm going to use it is going to be whichever one of these is the highest. Remember that this one has the invisible 1 for its power. And then we have 2 for the other power. So we're going to take that 2 because it's the larger exponent. So z squared is going to become the new denominator that I want. What's nice in this one is one of them is already having z squared as its denominator. So that second fraction, I can just write that down. The first fraction we're going to change so that it has z squared for the denominator as well. So 11z, and I'm going to do that costume change so that it now has z squared as a denominator, but still means the same thing. So starting at z, we're going to multiply by z to get to z squared. So z times itself will get me to z squared. And doing that in the numerator as well. So we would have 11z will be the new numerator. And going back over here, so now we can actually do the subtraction. So this stuff is kind of the behind the scenes costume changing that we need to think about. And then we bring it back over here to the actual subtraction problem that we're trying to do. This is all the, prep work we have to do to get those denominators the same. Now that we have them the same, we're going to do that subtraction, put it over the z squared. So 11z minus 8. And checking for any simplifying possibilities. These are not like terms. One has a z, one is a constant, and there's nothing we can factor out here. So we are just going to say, all right, we're done there. Now remember, this numerator has to be a single term before you start dividing things out. And since it is not a single term, we cannot divide the z's out. Okay, so make sure that the numerator is all one term with legal math rules. You can't just decide to change things up and if you don't like it. All right, we're going to look immediately below that one at 5/6 and 3/8. Just a little bit of a reminder on our LCDs there with the constants. So if we start with 6 for one of them and 8 for the other. So the 6 is going to be 2 times 3 when I break it into its prime factorization. 8 will be 2 cubed for its prime factorization. So the LCD is going to have to grab some 2's and some 3's. So then I figure out what are the powers. So I only have a 1 here. Remember the invisible 1 power there. So that means I'm going to take the 3 because that's the highest of the exponents on the 2's. So we don't add them, we don't subtract them, we just take whatever one's highest. And then we grab the 3 from above. So this will be 8 times 3 or 24 for the LCD. So taking each of those in turn, we're going to figure out what would the new fraction be with now the LCD as the denominator. And when I say new fraction, remember it's a costume change. We're not changing the value of the 5/6. It's still going to mean 5/6. If you put each of these into a calculator, you will still get 0.6 repeating. 0.83 repeating. But it will not look the same because we're trying to force that denominator to be the same so that we can add these up. So to get from 6 to 24, we'd multiply by 4, doing that as well in the numerator. So 20/24 would be the fraction I'm going to use instead of 5/6. And then remember, I'm going to force this one to have a denominator of 24 also. So going back over behind the curtain for my costume change for 3/8. So the 8 to 24, we're going to multiply by 3 here, and then we'll multiply by 3 as well in the numerator, keeping everything the same. And then we end up with 9/24. And at this point, we do have a common denominator, so we can go ahead and add those, keep that common denominator, and essentially we just squish that addition together in the numerator, but we don't remember denominator. We have it the same. We're going to keep it the same. Once you do that addition, you would get 29/24. 29 is a prime number, so I know it's not going to have any common factors with 24, which we had factored up over here. Remember, that's a bunch of 2's and a 3. So there isn't any simplifying we can do here. As an improper fraction, that would be the final answer. As a mixed number, it would be 1 and 5/24. All right, I'm going to pause for a second here while I flip over the page. All right, I realized I also needed to get my phone notifications turned on to silent. So, all right, we've now flipped over to page 22. So here we're talking about simplifying algebraic expressions with properties of real numbers. So we're going to look at the associative and commutative properties. This should be a review from Math 38 if you were in that or a previous math class. So hopefully this will help you out. All right, so commutative property of multiplication. You've known this forever. So if I flip the order of those two things that I'm multiplying, it doesn't change the answer. So it could be 4 times 3 or 3 times 4. Both of those are going to be 12. It does not matter. So order is not important. It can be switched or flipped. Now the associative property, another thing with the commutative property, if you think about commuting, some of you have to commute to campus or work, not for this class, but things like that. Commuting, it means there's some sort of movement involved. And that's what's happening here, right? We are interchanging the order of these. The numbers move. The variables move their order. So the commutative property, we're going to have movement with those values that we're looking at. The associative property has to do with how we group things. So it looks at what we do first. So in this left-hand side, it says, all right, we're going to do the A times the B first, then we'll multiply by C. And then over on the right, we're doing the B times the C first, then we're multiplying by A. But it's all good because we can group them in different ways and still get the same answer. In both situations, we are just doing 8 times 2 times 5. It's just a matter of which one we're doing first. So you'll notice with associative property situations, the order does not change. So the numbers aren't moving. The parentheses are going to move. So notice it'll be 8 and then 2 and then 5, just right, ABC, ABC. It's just the pairings, the associations, the groupings are changing on that. So if the numbers move, it's commutative. If the groupings move, it's associative. And then these same things follow through for addition as well. Notice we're not talking about division or subtraction because order is important in both of those situations. So 5 plus 12 would be the same as 12 plus 5. Okay. Doesn't matter which order we add them in. And then same thing with the associative property. So we're still going to have the same values in the same order, ABC, ABC, but which ones we which ones we associate together is going to be different. So that'll be 1, 2, and 3, but on the left we group the 1 and 2 first. On the right we group the 2 and 3 first. This is still going to be 6. This is still going to be 6. That's why that works. All right, flipping over to page 23. Okay, now there is a property with multiplication and addition that has parentheses, and that's the distributive property. The technical name is the distributive property of multiplication over addition. Typically, we just kind of shorten that to the distributive property. So when we have that, we're saying, okay, if the A is out here, and then we've got the B plus C in the parentheses, it means the same as if we multiply the A times the first thing in the parentheses, and then the A times the second thing inside the parentheses. So with numbers, it's going to look something like this, where we're going to do 5 times the 10 and 5 times the 2, which will give us 50 plus 10 or 60. And that's the same if we looked at this and followed order of operations. We would have 5 on the outside. This is 12, so 5 times 12, that is also 60. That's why it works. That's why we can say that those two things are the same. All right, now the max of these videos is 15 minutes, so I will pause this to put one last thing in and then get it uploaded. So make sure that you are multiplying A by each thing inside the parentheses, and that is going to take care of the distributive property. And we will look at the opposite of a sum in the next video.